strange person who comes and interrupts your excavation every so often, and a new group of volunteers wonders who he is. I do this a lot. I've spent my whole life wandering into other people's archaeological sites and making a nuisance of myself. I do it professionally, people even pay me for it, which is absolutely remarkable, but I do. I'm Dr. David Jordan. I'm a geoarchaeologist, geoforensic specialist, which means lots of different things. My background is in archaeology first, then geophysics, then soil science, then lots of years digging holes and finding buried things and running companies, and then research in how we detect things buried under the ground more effectively. I'm a member of the forensic anthropology team at Liverpool John Moores University. It's great that we have my colleague Julie Roberts, our programme director, here, and one of our students, Kiri, as well. Some of our students have been involved in the excavation. It's incredibly useful experience for them, learning how to use a mattock and to dig up bits of grass and put them neatly in a pile over there. But the business of the stuff that you're doing as well, all this delicate work, recovering the finds, taking things apart so you can see how they fit together bit by bit. It's very important in the discipline of forensic anthropology as well, because in those cases we're digging up human remains, and we have two very important reasons to approach it with this kind of delicacy. One is they're dead people. We treat them with immense respect. It's very important that we do. And secondly, if we don't do that, we don't understand what we're recovering, and therefore our evidence isn't useful. And what we're recovering is evidence, in this case archaeological, in the case of forensic anthropology, criminal, potentially, at least. Now, the wonderful thing about this site, for me, when I discovered that Vanessa, the site director, was going to be running the excavation, we were talking about being involved in a project together, is that not only is it very interesting itself, but it's also a site of real importance to Liverpool. It's hard to get more iconic than the statue of Billy Fury in the Albert Dock, and we're digging holes right next to them. And that's actually, for the people visiting, that's what they're experiencing. The Albert Dock, Museum of Liverpool, Billy Fury, Beatles everywhere, and then digging holes here. So there's this immediate connection to Liverpool as a city, Liverpool as a community, which I find absolutely wonderful, and I don't even come from here. You know, so that's really nice. And the fact that we have students from the university plus local people coming and working here. Are you residents locally? So this has got a special significance because you'll keep walking past this site every day and remembering what's under the ground. It's a little bit of inspiration for the future. That's really nice. Isn't it amazing also that with just a little bit of work we can reveal so much? You'd have never have guessed there was all this detail under the surface, would you? Because, you know, this is telling us so much, and all we've done is taken a bit of soil off and dug away really carefully to reveal what's there. Now, of course, we did know a little bit about it because we have documents like this. This is from the Illustrated London News. It's a 19th century picture, and it shows the piermaster's house and the other houses of the area as they were at the time. In reconstruction, some artist has created this picture for us. Very useful for us, although we don't know how much artistic license was used in this. We also have photographs, that's post-war, pre-war. We can see the buildings themselves here. That's a photograph of the houses we're digging through, which is very nice as well to have. So we have these kind of documents, but in addition to that, we've been doing geophysical surveys to map the buried remains before we excavated, for two purposes. The first purpose, apart from teaching and learning about the methods, which is important to us in the university, the first purpose was in order to be able to assess what the risks might be in digging holes in a piece of ground that might be unstable. You know, we don't know what's under here. It might well be that there are cavities. For example, if the geophysics can tell us that in advance, it's very useful because it means we can plan. And indeed that turned out to be the case. We identified there were areas which are probably rubble and maybe loose, and if we disturb them, they might collapse. And that's why the excavation has proceeded as it has, up to the cellar wall, there is a wall running through here, which the detection methods we used identified, and then the cellar itself we've left, or Vanessa has left, and we're just revealing the surface of, because by coming in from the side we were able to avoid the risk of breaking through. Now what we can see, in fact, is the cellar is full of rubble supporting itself. It's quite solid, so probably the risk is small. Nonetheless, it's useful. But the other reason to do this kind of survey work is that by mapping what's there under the ground before excavation happens, we can plan excavation. And we can work out, when we reveal something, like a wall, where does it go beyond the limits of the excavation? The geophysics will tell us that, even if we can't excavate all of it. So what is the geophysics? So we've carried out two types of survey here. One is a ground-penetrating radar survey. Ground-penetrating radar is like the kind of radar you point up at the sky to be able to see aeroplanes, yes, except it's pointing downwards. And the radio waves penetrate down into the ground, and wherever they encounter a change in the way in which the radio wave moves, you get a bit of reflection. This is the kind of picture we produce, which is a slice down into the ground, and it doesn't look like anything. It's just grey blobs, unless you've got some training and some practice. But this is actually showing us the cellar. I don't know if you can see, but if I were to show you that, you can see that it's kind of quiet there. There isn't so much disturbance, whereas here, there's variation. See what I mean? Not there, but there's variation in there. That's because the bricks and the stones of the cellar are sending the radio waves off in all directions, essentially, scattering the energy of the radio waves. That told us that there were things reflecting, but they don't really form surfaces, they don't form a floor or a ceiling. It showed us that it was relatively uniform all the way through. Hence the interpretation, rubble filling a cellar. Okay, so that made us think. Then we also did surveys. Well, here's a section actually through the radar survey across the site, and if you see that we are sitting, the edge of the trench is here, and you can see the coloured lines crossing, which are the radio reflections within the cellars of the building. So we can see where the cellars are. So you can see the cellar fills there, and that corresponds beautifully with the edge of the cellar here, the cellar fill, the far side is somewhere there, and this also fits the building plans from the excavation, from the original construction, which is very satisfying. It's nice to know that what we're doing has some kind of relation to reality. The other thing that we did was we measured the electrical resistance of the ground. Just finding the right pictures here. So this is a section, ignore the top two for the moment, it's the bottom one that really matters. The colours here indicate how easy or difficult it is to get an electric current to flow through the ground, the electrical resistance of the ground. Where you've got bricks with air between them, the electrical resistance is very high. Electricity doesn't flow easily through bits of brick with air, but where you have water in fine soil, like this stuff here, and further down undoubtedly, the electrical resistance is low. That's the blue colours here. And so you can see that here in fact we have the cellar remains, here we have the rest. And this is telling us, like the radar, that we have cellar and not cellar, yes, with a boundary between the two, but it's telling us more, because it's telling us that this stuff here must be quite fine and quite wet. In other words, the material here probably, the material there probably is the alluvium dug out of the dock, put within this to create the dock structure. Okay, and that's giving us extra information, which is really, really useful. And the great thing is that the picture that we get from where the remains are, where the cellars are, and the radar and the electrical work correspond exactly, and both correspond with the maps that we have. Which, from my point of view, is the guy who, with the students and with our community volunteers, organised the work. That's very satisfying, because you want to know that you've done it right. But also it's very useful for me to come back at this stage of the excavation to see what you're finding, because by doing that I'm able to understand why we got the geophysical results that we did. And from doing that I've learned something very important about the way that our techniques have worked, and so we'll do them better next time. So I just want to say thank you very much to all the volunteers who've been digging the stuff that will tell me such useful things, so I can just ride in one day on my horse, look down and say, I say that's absolutely wonderful, and ride away again, in the way that I tend to do. But also because working with my students, with the museum and so on, has been such a good experience for them and for us to be involved in community archaeology. So to the university team, to the museum team, to Vanessa and to all the colleagues, thank you very much as well. Any questions? Must be something. I've been talking for 10 minutes.
Can I just say thank you for involving us as residents?
Yeah, thank you.
Not
Yeah.
all really get the opportunity, and it's been really interesting.
That's fantastic. But of course, the thanks for the organising the residents' work here is with the museum, with Liz and with Vanessa. At the university, I think we can say that we are really happy that we're also working with the local community. So the guy who actually did most of the geophysical work in practice on the site is a local retired guy, retired here in Liverpool, who does a lot of geophysical work with me. And I'm so excited that we're able to tap into those personal resources, skills that people who've had their working lives, retired, that still have all those skills to organising things. We should be using them more and better, so that's wonderful as well for us.